Welcome to Shri Learning Academy. Let's simplify operating system. Imagine you just turned on your computer. The screen lights up, you see the company logo, and after a few seconds, your desktop appears. You might open your browser, play a song, or write a document all at once. But have you ever wondered what exactly makes all of that possible? What's happening behind the scenes, making your computer run smoothly and respond to your actions instantly? That's where the operating system, or simply OS, comes in. An operating system is like the invisible conductor of a very large orchestra. Each instrument, or in this case, each part of your computer, has its own job. There's the CPU that processes instructions, memory that stores information temporarily, disks that keep files, and input-output devices like the keyboard, mouse, and display. On their own, these components don't communicate directly with each other in any meaningful way. The operating system steps in to organize and control all of them, ensuring they work together harmoniously so you, the user, can get things done without having to deal with all the technical details. In the simplest terms, an operating system is a bridge between you and your computer's hardware. Without it, you would have to write complicated commands every time you wanted to do something, like move your mouse, open a file, or even see what's on the screen. The OS hides all those complexities and gives you a friendly interface, a desktop, icons, buttons, or even a command line through which you can interact easily. Let's take an example. When you open a music player and hit play, the song starts playing almost instantly. But think about what's really happening. The song file is stored on your disk, so the OS reads that data, sends it to memory, directs the CPU to process the audio information, and finally instructs the speakers to produce sound. You didn't have to tell the computer how to do all that. The OS did it automatically, following your single command. Now, operating systems aren't limited to personal computers. They exist everywhere in your smartphone, smartwatch, car navigation system, television, and even in some modern washing machines. For example, your Android phone runs the Android OS, while iPhones use iOS. Your laptop might use Windows, Mac OS, or Linux. Each of these is an operating system designed for a specific type of user experience, but the core purpose remains the same: to manage the system's hardware and software resources efficiently and provide an easy way for you to interact with them. You can think of the OS as a kind of manager, actually, a manager with many departments under it. It manages memory, deciding which programs get which parts of memory. It manages processes, deciding which program gets to use the CPU and for how long. It also manages input and output devices such as printers, disks, or keyboards, ensuring they don't conflict with one another. And finally, it manages files, how they are stored, retrieved, and protected. We'll talk about all these functions in detail later in the course, especially in topics like process management, memory management, and file systems. But for now, it's important to remember that the operating system acts as a coordinator that keeps the entire computer system running smoothly. Another great way to understand what an operating system does is to imagine running a big restaurant. You, as the customer, walk in and place your order with the waiter. The waiter doesn't cook the food, but he takes your order to the kitchen where the chef prepares it. Then the waiter brings it back to you. In this scenario, the kitchen represents the hardware, the stove, the ingredients, the chef's skills, and you represent the user. The waiter, who handles communication between you and the kitchen, is the operating system. He ensures your request is understood, manages the order queue if there are multiple customers, and makes sure everyone gets served properly without chaos. That's essentially what the OS does. It takes your requests, like opening an app, copying a file, or connecting to Wi-Fi, and translates them into instructions the hardware can understand. It also makes sure that if several programs are running at once, each one gets fair access to resources. For instance, when you're listening to music while typing a document and downloading a file, all three tasks seem to happen simultaneously. But in reality, the CPU is rapidly switching between them thousands of times per second, and it's the OS that controls this switching, making multitasking appear seamless. Now, if we talk about how an operating system actually functions, we can think of it as having two main layers, the kernel and the user interface. The kernel is the core part. It has full control over the hardware and manages all low-level tasks like memory allocation and CPU scheduling. The user interface is what you see and interact with the desktop, menus, icons, and touch gestures. We'll explore this distinction more in later topics like kernel versus shell and operating system architecture. But for now, just remember that the kernel is like the heart of the system, while the user interface is the face. In summary, the operating system is the core software that makes your computer or device usable. It's what allows you to communicate with your hardware without needing to know how the hardware actually works. It manages all resources efficiently, keeps everything running safely, and ensures that users and applications can share the system without interfering with one another. Without an operating system, a computer is just a collection of parts, a lifeless machine waiting for instructions. The OS breathes life into it, turning it into a tool you can use to create, learn, communicate, and explore. So the next time you start your laptop, tap your phone, or even set a timer on your microwave, remember, behind that simple action, an operating system is working quietly, tirelessly, making everything happen. That is it for this video. See you in the next one.